Hello and welcome to this video where we're going to be looking at the sine rule. And you can see on the screen, I've gone ahead and written out the sine rule here like so. Now, the sine rule you're going to use on any kind of triangle, and when you're using the sine rule, you should start off by labeling your triangle. So we can label the triangle, any angle will have a capital A. Opposite that angle, we will have the side with the lowercase a. And then if you choose a different angle, we could label this one here, for instance, B, and then that means the side opposite will be lowercase b, and then the last one will be C and capital C. Once you've got your triangle set up like this, then actually you're going to use any two of these equalities here like so to work out missing sides or missing angles. Let's see how that works in practice. So here you can see I've got a triangle on the screen and we are trying to find this side here, X. Now I'm going to go ahead and label like so, and I will start off by labeling this angle here A, and so the X therefore will be small a. This angle will be B, and so therefore the 10 will be capital B, and then this last side would be C and lowercase c, but as you can see I'm actually not going to be using this in the question, the C and the lowercase. And then you look and you see which ones you want to use, and in this case we have these first two like so, and then I can set up my fractions. So I start off with the small a, which is X, over sine of capital A, which is 40, is equal to, and then I'm looking for, and then I also have B, which is going to be filled in with 10, over sine of capital B, which is 50. Now we're going to go ahead and solve for X. At this point, you could put this, the right-hand side of the equation, into your calculator and evaluate that. And if you do, you would find that this here is about 13.05. I'd probably recommend to leave it how it is and rearrange first, because if you round anything, you could end up making a small mistake if you round it too much. So I will leave this as so, like 10 over sine 50, and I'm just going to multiply up by the sine 40. So what I'm doing is I'm just taking this part here and rearranging the equation by bringing it up onto the other side and multiplying. Now, once you've got it like this, you can go ahead and type that whole thing in your calculator. If you have already put this in your calculator and got 13.05, then you can just do times sine 40 to work out the final answer for X. And then you will get X as being equal to 8.39. And I'm rounded to 2 decimal places. Now you can see here on the other side of the screen, we have another triangle. So if you'd like to pause the video now and see if you can work through this problem in the same way I did and work out what that side length X is. Okay, if you have done that, then you should have done something like so. So no matter how you label up this triangle, you should end up with X over sine 30 on one side of the equation, and then 6 over sine 20 on the other side of the equation. And then you can multiply this by sine 30 to work out a final value for X. And you should have got 8.77. If you didn't quite get that, then feel free to pause the video and have a look through my workings out. Okay, that was how we find sides. We can also use the sine rule to find angles. Now, if you want to find angles, I would recommend you swapping the numerator and the denominator. So this, the sine rule can actually be written two different ways. And the other way we can write it is by putting sine A over A is equal to sine B over B is equal to sine C over C. And this is actually exactly the same. You can use either equation for any type of triangle, but it's easiest if you use this one to work out sides, and then if you use this one to work out angles. So let's look at another problem. So here you can see on this triangle, I'm looking for this angle here, and I could go ahead and label the triangle so that I can use the sine rule. So if I label the missing angle to be the capital A, then that means the side opposite here, the 10, is going to be the lowercase a, and then this one I will label capital B and lowercase b, and then again we don't have anything for C. Now once you've done your labeling, we can substitute into the sine rule. So this time I have sine of A, which is theta, over lowercase a, which is 10, is equal to sine of 40 over lowercase b, which is 12. Now again, you could put the right hand side into the calculator now to work out what that is, and you will get that as being equal to 0.0535. And then again, what we're going to do is we're going to rearrange for sine of theta. So I'm going to multiply up by 10. Sine of theta is equal to sine 40 over 12 multiplied by 10. Now this is the case where I would go and evaluate on the calculator if I haven't already. And if you type that in, you will find that you have sine of theta is equal to 0.5356, and it continues. Now we want to work out what theta is, not sine of theta. And so in order to work out this value here, I need to use the inverse sine function. So I wouldn't usually write that down, but you can if you like. But what I'm going to do for this next step is I'm working backwards. I have the answer. I want to know what the angle is. And so instead of sine, you need to use the inverse sine, which is going to look like this on your calculator. And that is usually above the sine button. So shift sine will get you that. And then you put the 0.5356 in, and then you press equals, and you will get the angle theta as being equal to 32.39. Okay, so again, if you'd like to have a go at a problem yourself, there's another one on the screen there. You can pause the video, get a pen and paper, and see if you can work out what that angle is. Okay, so if you have done that, you should have an answer that looks like this. Here's how you build up your fractions. And then working through, you should get the angle as being equal to 43.16. If you didn't manage to get that, then again, you can pause the video and see if you can work out how I did it. Okay, now this is the previous problem, the one that you just worked on, the 43.16. And I just want to point out something, that if you have a triangle with a side length of 10, an angle of 20, and a side of 5, there's actually two valid triangles that will still have all the same values. And I want you to imagine that you have like a hinge here at this point, and then you're going to let this side length 5 swing. And if you let it swing, it will drop down and it will go back up, and eventually it will meet this line again somewhere here. And so you can see that this new triangle has the same side, 10, also this angle, exactly the same, 20, and this side is still 5, but actually theta is now like this. And you can see here that this theta is acute, so it's less than 90 degrees. This one is obtuse, so more than 90 degrees. So if you have a triangle that looks like this, then you're going to use the sine one exactly the same way. So you need to build up your fractions the same. You're going to have sine of theta is equal to sine over 10 is equal to sine of 20 over 5. You start off with the same problem, and then when you get to your answer, you will still get theta as being 43.16, which obviously for this triangle is not correct. All you need to do to get the correct answer for this other theta is do 180 minus 43.16, and that will get you to 136.84. And that's always the method you use, so you can always do 180 minus the angle to get the second angle. The reason for that, if you want to know why, is if you look back at the triangle at the top, this is actually an isosceles triangle. This side is the same length as this side, which means that this angle here is the same as this angle. And obviously you can see that this is a straight line. So if you do 180 and subtract that from it, you will have the missing obtuse angle. Now, in order to spot this type of question, your examiner should make it pretty clear. So they might tell you theta is obtuse, or they might tell you that this value here, 10, is actually the longest side. You can see here in the original problem, this side would have been the longest side. And then in our problem, this side is the longest side. So if you have that 10 as being the longest side, it means that the angle opposite is the biggest angle. Okay, I have one last problem for you to have a go at. So pause the video and see if you can work out this side here, x. Okay, if you did try that, the trick to answering this question is to spot the angles in a triangle add to 180. So we actually don't have this opposite angle here. And that opposite angle, you're actually going to do 180 minus 60 minus 20, and then you can work out that's 100. Once you've done that, you're carrying out the process the same as we did before. Thank you very much. I hope you all have a great day. If you did find this video helpful, then please like the video and it will help other students such as yourself find it.